Hello, you want to get some materials for today? You need some graph paper, notepad paper, some rulers, pencils, erasers, just in case. For today's transformation, first we need to set up our graph papers. You need to pay close attention to the following directions. Hold the graph paper in the portrait position. Draw 2 lines through the center of your paper for the axes. But it's important here to note, do not label these lines or number these lines. Are your axis lines on lines and not above or below them? Good. Now, turn your papers over and draw another set of axis lines directly on top of the set of axis lines on the other side. If done correctly, your paper will look the same on either side. If you hold the paper up to the light, you should see one X and one Y axes. Okay, on top of one side of your paper, write the word front in small letters. Then flip the paper over, going from right to left or left to right, and write back in small letters on the top of that side. Now, you'll need to flip the paper over to the front and plot these 3 points that you see on the screen, A, B, and C. You're going to connect those lines. It should look like the picture below. It should be a right triangle, is in quadrant number 1. Okay. Now carefully, I would like you to use your pencils to poke a small hole through each of the 3 points you just plotted on the front side, so that when you turn your papers over, you'll be able to connect the 3 points on the back side. Label these 3 points with the same letters you used on the front side. Your paper should look like the picture below. Your triangle will be in quadrant number 2 here. Now turn your paper with the front on the top of your paper, and the triangle you've made is in quadrant 1. Before we reflect our triangle across the X and Y axes, I want you to create a table to record your original points and the transform points of the new triangle. It can be as simple as the example I've done below. But vocabulary alert. As you can see, the new points have an apostrophe mark on them. These are called prime. When transforming shapes, A prime is called A prime, or B with the apostrophe is called B prime, and so on. These marks distinguish the original figure from the transformed figure. If you were to look at a graph and it had 3 congruent figures in different locations on a graph, and the points were labeled A prime, and A double prime, for example, it lets you know which figure is the original, which figure was the second transformation, and which figure was the third transformation. Here we go. Let's reflect our triangle across the y-axis. With your triangle in quadrant 1 in front on top, turn your papers over going from the right to the left. The top of your paper should now read back, and your triangle is in quadrant 2. These are your new transformed points. Now fill in your table with the 3 new point locations. What do you notice about how the point locations changed? The rule for reflecting an image across the y-axis is the y value stays the same and the x value becomes its opposite. This is the same as x being multiplied by -1. Make up another table for original points and transform points to record the point location when you reflect an image across the x-axis. You'll see the table below. This is done by turning your paper over from top to bottom or bottom to top. What is the new rule for reflecting across the x-axis? That's right. The x values stay the same and the y value becomes their opposite. Y is multiplied by -1. Okay, now try to fill in the answers to the table below. I've given you the original point, I've given you a transform point, and try to fill in which axes must that point have been reflected over, either x-axis or the y-axis.